All right. Well, all the satellite advances mentioned by Matt are also being taken to another level, thanks to the integration of other types of cutting-edge technologies, tools, and methodologies. Some of the greatest innovations are in the use of new devices, such as drones and radar, but the most impressive advances are computer-based resources derived from the use of artificial intelligence, machine learning, and cloud computing. I'm going to talk about these technologies in the next few minutes and how they are complementing the satellite monitoring in the fight against illegal deforestation. Next, please. In recent years, drones become the most attractive and cool tool for monitoring and surveillance because they are relatively cheap, user-friendly, and can cover vast areas. As part of our work in Conservación Amazónica, we built a comprehensive model to combine this big mass data from early deforestation alerts as GLAD system with the analysis of satellite imagery and provide that to local communities and authorities so they can use drone technology to obtain image, to obtain evidence of illegal activity and plan an action on the ground, as well as using as legally admissible evidence in courts to prosecute offenders. Next, please. Matt, are you there? All right, thank you. Another technology that complement the satellite monitoring now is radar. Radar is an active remote sensing technology that has the advantage of being able to see through clouds, which is something that a regular satellite, that optical satellite can't do. So using radar allows us to have information even in the long rainy season where there are a lot of clouds covering the rainforest. Earlier, Dan showed the results of our participation on the NASA USAID Servir Amazonia program, where we developed this web app that allows us to monitor deforestation caused by mining, by gold mining, using radar technology. This online tool called RAMI, from Radar Mining Monitoring, it's a new way to complement our deforestation monitoring activities, and it allows us to give us decision makers real-time information of mining advance through the entire year, rain or shine. Next, please. Also, Dan, in his presentation, talked about this huge number of satellites that have been launched into space. Currently, we have more than 500 Earth observation satellites orbiting the Earth. The amount of information generated increased exponentially in the last 5 years. So we moved from talking about gigabytes of information to talking about petabytes of data. Since one petabyte is equivalent 1 million gigabytes, you can imagine that a new challenge is storing, sorting, and analyzing this much data in a way that is fast and reliable. Next, please. First of all, we moved from a traditional approach, which really heavily on the hardware and software capabilities of wherever was analyzing the data to develop a final assessment of what the data means. Now we are overcoming these issues around hardware capacity by using virtual tools such as Google Colabs, which is short for Collaboratory, which give free access to computer resources from Google company. In terms of software, new platforms such as Google Earth Engine and the Google Cloud help improve our efficiency in processing, storing large amounts of data, and viewing the results through the generation of very nice web apps. My colleague Matt Feiner showed a new fire tracking app based on aerosol monitoring. We were able to create this app by gathering traditional satellite monitoring and apply the Google Earth engine and other big data technologies to cross-reference the satellite information with thousands of fire alerts from NASA, from the firm's initiative. Next, please. The last advance that I want to cover is the artificial intelligence. Matt, during his presentation, showed how we want to do this next step regarding the detection of these small pieces of losses like produced by illegal logging. Now, well, AI opens up a world of opportunities for the implementation of threat detection techniques based on coding and programming. The best example of how AI is changing the forest monitoring approach are the GLAD alerts from the University of Maryland. This system based on machine learning algorithms that use satellite image to automatically detect forest loss every 16 years is spread along of the worldwide. Today, by integrating artificial intelligence with very high resolution imagery, we can even detect these smaller losses, most of them generated by illegal logging single trees in the Amazon. And by training machines using these AI models and using automatized detection algorithms, we can understand the real impact of illegal logging, which is something that traditional satellite imagery alone could not do before. Well, these technologies can help take a real-time satellite monitoring of deforestation and forest degradation to the next level and give the communities and authorities the information they need to take immediate action.